Hello everyone, I am Dr. S.K. Dixit. Today I am going to discuss the charging and discharging of the capacitor experiment, finding the time constant. The title of the experiment is study charging and discharging of a capacitor and find out time constant of RC circuit. Main focus to correlate time constant value by theory and graph, that is experimental observation. We have to plot the graph time versus voltage and time versus current during the charging and discharging of the capacitor. Formula used here: the charge at any time t is equal to maximum charge bracket 1 minus exponential minus t upon RC. Voltage at any time t is equal to maximum voltage bracket 1 minus exponential minus t upon RC. Current at any time t is equal to maximum current exponential minus t upon RC. Here Q is the charge on the capacitor, V and I voltage and current respectively on the plates of the capacitor, R and C resistance and capacitance of the circuits. Resistance is measured in ohm and capacitance is measured in farad. The E value is equal to 2.71 when we are putting the T is equal to RC. So this is calculated. The voltage at any time t is equal to 64% of the maximum voltage of the capacitor, and the current at any time t is equal to 37% of the maximum current. Now we are discussing the circuit diagram. Basically, the DC power supply here, it is 0 to 20 volt, and switch SW1 is there, SW2 switch is there, emitter it is connected in series, and resistance connected in series, capacitor of the 1000 microfarad and resistance 50 kilo ohm. We have to take the observations for this resistance and this capacitance, and voltage is connected in parallel for measuring the voltage across the capacitor. So this we are seeing here that the power supply and switch S1, SW1, emitter, resistances and capacitances are connected in series, while the voltmeter is connected in parallel. So this is the circuit diagram for determination of the time constant of the RC circuit. Basically, now we are going to define what is the time constant. Basically, first of all, the capacitor acts as a charge storing device. The time interval is time in which the voltage falls in capacitor up to 64% of the maximum value in the charging case and 37% of the maximum voltage in the discharging case. There are two cases, charging case and the discharging case. By knowing the time constant, how long capacitor will retain charge up to certain level, this scientific information we are getting by the time constant. It is useful in the RC oscillators, RC amplifiers, filters, inverters and dipolar nuclear particle counting systems, etc. The very important conclusion is drawn here there are two cases. Charging case, the voltage increases exponentially with time, while current decreases exponentially on the positive side. While in case of the discharging of the capacitor, voltage decreases exponentially with time, while the current increases exponentially on the negative side of the. Now we will proceed for the charging and discharging of a condenser kit. Basically, all the components are internally connected here, and this is the power supply 20 volt. This is switch 1, switch 2, switch 3. We are not using this switch, and various capacities, resistors are there. Various capacity, the capacitors are here, resistances and capacitors are there here. Suppose we are studying the charging case. So charging of the condenser, the key gets on, while this S2 key gets off. So what happens? The battery gets connected in the circuit, and the charging starts. This is the observation table which is devoted for the charging of the capacitor, and we have taken the time in the interval of the 10 seconds, 10, and we are observing the time here, time by the stopwatch here, and of 10 second the voltage across the capacitor is 1.96 volt. 20 second the voltage is increases 3.05, and so on up to, by increasing the time interval, the voltage is increasing manner is observed here, while for the current across the condenser, when at the 10 second the reading is 0.1 ampere, and 20 second the 0.08 ampere, 30 second 0.06 ampere. So what happens? The observation is the current is maximum at the 10 second, and it is gradually decreasing and gets constant at the maximum time interval 90 second. And by these observations I have plotted the graph time versus voltage. Time is taken on the x-axis in the interval of the 10 seconds, and voltage is across the capacitor is taken on the y-axis in voltage. The scale is taken in the x-axis is 10 division is equal to 10 second, and the in y-axis 10 division is equal to 0.5 volt, while we are showing here the voltage exponentially growing during the charging of the capacitor, and voltage is exponentially decreasing during the discharging of the capacitor. At the maximum at 10 second the maximum voltage is observed here during the decay 7.21, and hence by this graph I have calculated the time constant by the graph. By charging case 63% of the maximum, and the maximum voltage is 7.21. So when this is calculated, it is around 46 seconds for the charging, and for the discharging case the 37% of the maximum, and the maximum voltage is observed 7.21. so this is the 27 second by the graph, while we are taking the average of 46 second and 27 second, the average value is
37 seconds. This is the achieved outcome of the time constant by this graph. The similar observations is taken for the time versus current plot. Basically, this is the observation table where the time is taken in the increasing of the 10 seconds interval of time, and the voltage across the capacitor, the readings are taken at the 10 second 7.21, at the 20 second 5.7 volt, and hence we are observing as we are increasing the time, the voltage is gradually decreasing, and for the current at the capacitor, when we are taking the readings, we are observing here at the 10 second the current value is 0.1 ampere, and at the 20 second at the current value is 0.09 ampere. Hence the current value is gradually decreasing order as increasing the time, and by these observations we have plotted the graph of time versus current, where time is taken on the x-axis in seconds. The minimum reading and 10 division is equal to 10 second, and here we are observing when we are increasing the time, the current is exponentially decay for the positive side from maximum to minimum value, and the current is basically variation is noted here. For at the 10 second the value is 0.1 ampere, and it is exponentially growing here, and we have calculated the time constant by this current versus voltage plot. It is 37% of the maximum current. It is calculated 40 second. Now we have drawn the conclusion. The time constant measured by the graph is 37 second. It is the achieved outcome, and time constant measured by the theoretical calculation T is equal to RC 50 second, and this is the expected outcome. And one very important precaution always keep in mind while discharging the capacitor, current suddenly changes here, hence we have to note current quickly and accurately, and hence the time constant is playing very important role in the RC circuits, which is basically useful for the RC oscillators, all RC amplifiers, inverters, and the nuclear particle counting systems, etc. Thank you. Have a nice day.